Hello, in this lesson, we're deciding whether this infinite series converges or diverges. And what we're going to do here is identify the pattern. So starting with the first term, we know that it's -3. And then we have +9. And then next is -27 and +81. And then the pattern continues, right? By multiplying by -3 as what you see here. Now, I also want to point out is that the plus signs don't matter because every series uses plus signs when we're adding the terms. What matters is the pattern inside the terms. And so, as you can see, we are multiplying each term by -3 as I've stated. Now, since each term is multiplied by -3, this is known as a geometric series. So we have R, and I'll write R equals -3. Okay, so let's go ahead and define a few things. So we'll define A. A is known as the first term. So I'll write first term here. First term. And then R is our common ratio. So that is common ratio. Okay. That means that A equals -3 and R also equals -3. And then another thing I want to point out is that a geometric series converges only if the absolute value of R is less than 1. Okay, so let me go ahead and write that down. And I'll write a geometric series. A geometric series. Geometric series converges only if the absolute value of R is less than 1. Okay, very important. So let me just go ahead and highlight that really quickly here. So again, a geometric series converges only if the absolute value of R is less than 1. So let's go ahead and apply the rules step by step then. So we have the absolute value of R, which equals the absolute value of -3. The absolute value of -3 equals 3. So the absolute value of our ratio is 3. Okay, now we're going to write the comparison step. So that means 3 is greater than 1. So if you're comparing the two, the absolute value of R is less than 1, the absolute value of R is equal to 3. So that's where 3 is greater than 1 comes from. This is very important because it shows the reasoning chain. So what I want to say here is that this infinite series diverges, right? So I'll write diverges. And that's the final answer. Now, since the ratio has an absolute value bigger than 1, I'm just reiterating this, the terms do not get smaller. That means this infinite series diverges. Okay, so that's the meaning of that. And that's the final answer. So if this was helpful, please give it a like, please subscribe, and leave a comment in the comment section below as far as what helped you. And as always, keep practicing and stay tuned for more calm, clear math lessons right here on MathByTV.